In this video we talk about Cloud Code. You need to understand, at least on a high level, what Cloud Code is before we can install it and before we use it. Now first of all, Cloud Code is normally a closed source tool. We know roughly how it works, but Cloud Code itself doesn't tell us all the detail. But luckily, Cloud Code had a source code leak. And that's why we also have a project that is called Cloud Code, and Cloud Code is 100% open source. This is a rewrite from TypeScript to Python, so Cloud Code is created in TypeScript, and this thing is created in Python and Rust, and that's why this thing can stay open source. They have also a complete web page where they explain us a tiny bit about the architecture and so on. Of course, also Cloud Code itself gives some information, and that's why we know in detail how everything is structured. And I have made something relatively cool. I have created with Cloud Code a web page that explains us in detail what Cloud Code is. Cloud Code is basically just a model wrapper in a harness. So as soon as you see this thing right here, this is Cloud Code inside of VS Code. Don't worry, I will show you all of this, and this is a project that we make inside of this course. We have sub-agents and so on, but every single time as soon as you talk here to Cloud Code, you will talk to the LLM, so the model, in this case Opus 4.7. And this model is only powerful because there's a harness around it. The model can generate text or code, and the harness gives it tools, context, permissions, and a loop for doing real work inside a code base. The model itself, so in this case Opus, the LLM that generates our code and text, can only reason, it can plan, and it can choose tool calls. The harness around it can execute actions and feeds results back into the context. The context itself comes from the chat history, from searches, from file reads, and from the cloud.md. So every time as soon as you ask here something, I will show you. Explain the project. The LLM will basically use the harness. The harness will understand that it needs to list some directories, then it will basically navigate to them. It will read this directory, so here you see that we read here some stuff. We read 3 files right now. And we do all of these tool calls one after another, relatively agentic, because the harness around the model steers it in the right direction and tells it what to do. It will read most of this file, and most of the time it will start with the cloud.md. The cloud.md is just a file that guides Cloud in the right direction. Then the outcome is obviously an AI that can inspect, edit, run, and explain code. The simple definition is, a harness is the operating environment around the model that turns text generation into real actions. What all of this means? The useful mental model is not the AI magically edits code. The useful mental model is, the model asks, the harness does. Without a harness, you have only text or code generation, no real file access, and no command execution. With a harness, you can read, search, edit, bash, git, and so on. You have permissions and safety gates, and you have session memory and workflow control. I will show you for a brief moment the safety permissions. If we say, for example, make the colors of the front end more vibrant, and if we send this out, the harness will guide the LLM in the right direction. It will understand that it needs to edit this index.html, so it will read this file, then it will think a bit, then it will generate the code as you see right here. And here you can see right now the permissions. Do you want to make this edit to index.html? Yes, yes, and always for this session, or no. So if you want to change this, you can do yes. If not, you can do no. And if you want that Cloud Code can make these edits for styling all the time in this specific project, you can allow it always. For right now, we will simply take here yes, and then we will have a little bit more vibrant colors here included. Now next, Cloud Code thinks that we should change a little bit more stuff, and we allow it one more time. And so it goes on. Cloud Code always asks me if it can change these colors right here. And it does it completely automatically, and you can even bypass these permissions if you want to. So if you want to give it even more autonomy, you can absolutely do this. And of course, the harness also includes session memory and workflow control. You have not only the context window, no, you have also a cloud.md where Cloud will always have a little bit of context for itself. And why all of this matters? The same model can perform very differently in a different harness. We have open code, we have codecs, we have a lot of harnesses around these models, and every single one of these harnesses will perform differently. We have also OpenClaw, we have the Harness agent, and so it goes on. The tool design and context quality change the outcomes massively. And a good system beats vague AI magic. Now we need to talk about the harness itself for a tiny bit. How is the harness architecture working? We always have an LLM, so a large language model, and the LLM will always plan, reason, and emit tool calls. Then we have the tools itself, for example, read, search, edit, bash, git, and so on. We have all these permissions, so if the LLM wants to do a read, it will most likely not ask, because this is not tragic. But if it needs to change code, it will ask. If it needs to run a bash command, it will ask. And if it has to edit the code, it also has to ask. And you can allow all of this, or the model will ask you, as you saw, and you can also deny it. And you have also the context in the harness, with the history, the outputs, and the Claude.md. All in all, we do have our orchestration loop. We will execute, we will append the result, and then we continue. The core idea is simple. The model only knows what's inside the context, and the harness decides which tool exists and how they are described. The harness executes the real action after a tool call. The result is pushed back into the context so the model can continue. And this loop is what makes Claude Code feel agentic. Here you can see everything. So I asked this question. Claude Code reads everything that it needs. Then it will start the changes, it will ask me the changes, and it will run tool call after tool call, and the LLM works every single task one after another, and that's why this thing feels so autonomously. Because the harness around it always guides it to read the right files, to execute the right tool, and then at the end you will have something like this. So the changes, the palette shift, we have added some stuff, we have a user bubble, and Glow Alpha is also pumped a bit. And if I open up this chatbot right now, we do see that we have a little bit of glow included. The whole action loop of this harness is something like this. You give a task, for example, find a bug, fix it, and explain the change. Then, the model will choose a tool. It may search, read a file, inspect, tests, or run a command. Then the harness will execute it. The action happens in the real environment with permission checks. Then the output goes inside the context, so the model now sees the result and decides the next step. And we loop it until it's done. We read, we edit, we run, we verify, we explain. Just like you see right here. We change a bit of code, then we read a few files again, we change once again a bit of code, we read a few files, we change again, and so the loop goes on until everything is done. Claude Code in one sentence. A language model becomes a practical coding agent when a harness gives it tools, context, permissions, memory, and a loop for completing tasks. The core concept of such a harness, so the building blocks of it, are of course the tool system that can read, search, edit, bash, git, and sometimes it can also use MCP or even CLIs, and so it goes on. Then we have the context engine that will load the information the model needs, instead of stuffing the whole repo in the context. If you have a big code bases, of course you cannot stuff everything in the context window of an LLM, because the context window is always limited. So the harness needs to decide what should get stuffed inside of this context window, and the harness around it is really good in that. Then we always have the permission layer that will control safe access. If you ask to delete something, Claude Code will always ask you if this is okay. Then the session itself, it will keep transcript history and task continuity, so work can continue instead of restart code. We also have a bit of orchestration. This will run the cycle from prompt to tool call to result to next action, so it will all run in a loop. And we also have the project memory itself. Files like the Claude.md reload rules, structure, and expectations. I will show you the Claude.md for a minute. Inside of this project we have none, but if we do /init, we will get one. And don't worry, you will learn all of these commands. But first you need to understand all of this on a high level, so what's going on. Because this is not really magic. There's just an LLM inside the harness that can run some stuff. The harness is created in a way that the LLM has to read this Claude.md. And inside of this Claude.md, there's a really nice structure of the whole project. And because of this Claude.md, the LLM with the harness will have a good time understanding where to search. It will also understand when to use what agents. If you see right here, under .cloud I also have some sub-agents. I have an agent, for example, for backend, I have something for frontend, something that can test things, and it will all understand this because it can read the cloud.md and it will use the right stuff at the right time. The best takeaways from all of this: Cloud Code is not just a model. Cloud Code is the model plus the harness. If you use a plain vanilla model over an API, it can just generate some code, but it will not have a lot of context. Because context is everything, the model only knows what the harness gives it. The better the harness, the better the result. The tool design, prompts, and permissions change the performance a lot. If you don't have a good harness, the LLM itself can be as good as it wants to be. It will not work that great. And lastly, it is a system design. The magic is mostly architecture and not sorcery. So all in all, you understand what Cloud Code is. Cloud Code is simply an LLM stuffed in a harness, and the harness gives it tools to execute stuff relatively agentic. And that's why tools like Cloud Code feel magic. And right now I do think you understand what Cloud Code is, and we should go on, install it, and learn everything that we need to know.